Section 1.2, segment addition. We have a little 5-minute check at the beginning here. I want you to go ahead and read through these and see if you can figure out what the answers to each of these would be. Now we have to make a slight adjustment that I didn't have here. Name 3 collinear points, that's fine. What is another name for line AB? Name a line in plane Z and name the intersection of plane Z and W. Go ahead and complete those 4. You can pause it here. I'm not going to give you the answers, but if you want to take time right now to do that, go ahead and pause the video, do those 4 problems, and then we'll get back to the segment addition property. All right, the segment addition property says this, and we can put this straight on our Cornell note sheet if you'd like. So instead of writing it here, you can put this on your Cornell note sheet. If we have a segment A, B, C, okay, what it tells us is that we can take the 2 parts. We can take part 1 and add it to part 2, and that would equal the whole segment, which makes sense, right? If I take a piece, if I have 2 rods that make up a complete rod, I can add the 2 rods together and it'll get the length of the 1 large rod. So in this case, part 1 would be segment AB, or the measure of segment AB, and we're going to add the second piece to it, segment BC, and we add this segment to this segment. It's going to give us the whole entire segment, or the measure of the whole entire segment. Now notice I'm not putting segment lines above these, because when we don't put the segment line above it, that means the measure of segment AB, the measure of BC equals the measure of segment AC. So when we put a segment above it, it's discussing the actual diagram. If we write it like this, the measure of AB, then we're talking about a number, okay? So segment addition property, I often say part plus part equals whole. We're just adding the 2 parts together to get the whole thing. So you can put that here and add it to your Cornell note sheet as well, but you do need this on your Cornell note sheet. Now moving on, it says find the length of each unknown segment if y is between x and z. Draw and label a diagram. So here's x, here's z, and all we know is that y is between it. Is it halfway between? Not necessarily, so you need to be careful there. Okay. It's just somewhere between. So if I draw my segment, y is somewhere between. I don't want to put it in the center because I don't want you to think that the 2 are equal. Okay, so we'll put it somewhere not in the center. Now, we want to label what we know. The measure of xy is 5p. So between x and y, this is 5p. Between y and z, that's just p. Now your diagram in geometry is not always going to be drawn to scale. So don't worry about that if you notice that if that's 5p and that's p, that this can't possibly be in the right place. Don't worry about that, okay? We just needed y somewhere between for this to work. It'll still work out. So xy is 5p, the measure of yz is p, and the measure of xz is 36. Now if you want to show the measure of xz, you need to use a bracket, either above or below. Let's do one above. Now, what this is saying is from x to z, it's 36. You have to use a bracket, otherwise you're not sure which piece you're talking about. You can't just write some number floating out in the middle. Maybe that doesn't make it sound like such a big deal to you right now, but when we get into much more difficult drawings and diagrams, you need to label them properly, or you're going to be very confused about what you have labeled in your diagram and what is really true. So you must use a bracket here. There's no choice on that. Now, we have a segment with 2 parts. If we write a segment addition property statement like this, for this diagram, we would get the measure of xy plus the measure of yz equals the whole thing, the measure of xz. Okay? Now, All we need to do is take what each of these segments measure. So if xy is 5p, we put that in place of xy. It'd be substitution if we were doing a proof. And instead of putting yz here, yz is p. So we're substituting p in place of yz. And in place of xz, we know xz is equal to 36. You can either look up here or look at the diagram. So we just did a substitution step. And now it's just algebra. We're just solving this. 5p plus p is 6p equals 36. And then we want to divide both sides by 6. So we get p equals 6. Now it says find the length of each unknown segment. So the measure of xy equals the measure of yz equals, and so xy, go back to the diagram, is 5 times p. Now if p is 6, then that's 5 times 6, which would give you 30. Yz is just p. So if p is 6, then yz is simply 6. Now you can always check these, because if xz, the whole segment, is 36, then these better add up to 36, and it does. So we're good. Good to go there. Let's try number 6. We're talking the same diagram, so x on one end, z on the other, and y somewhere in between. xy is 2c plus 1. So between x and y along the line, write 2c plus 1. yz is simply 60. And xz, from x all the way to z, it's 7c plus 11. What you need to understand is that the one that has the measure is not always going to be on the right side of the equal sign. You've got to follow the diagram. So again, if we write a segment addition statement like we did here, xy plus yz equals xz. Now just start plugging in what we know. xy is 2c plus 1. So putting that here in place of xy. Okay. yz is 60. So instead of yz, we write 60 in its place. And xz, from x to z, is 2c plus 11. Just a simple substitution. Now, if you're not drawing the diagram, you'll probably won't set it up correctly. So I will require that you draw a diagram, that you label not only the points, but the measures along each of the segments and use brackets, and then simply do part plus part equals whole. The rest is algebra. So we can simplify the left side to get 2z plus 61 equals 7c plus 11. Now we want to collect all the c's on one side, so I'm going to go ahead and move this 7 over this way by subtracting 7c. So I get negative 5c plus 61 equals 11. That's okay. Now we're going to move the 61 over this way by subtracting 61. So we get negative 5c equals 11 minus 61, which will be negative 50. And then when you divide both sides by negative 5, you'll get c equals 10. There are other ways to solve this, so you don't have to solve it the way I just did. Now if c equals 10, then we are looking for xy, yz, and xz. Now technically we already know what yz is. It's 60, so we'll go ahead and write that in. Xy is 2c plus 1. So if c is 10, that's 2 times 10 is 20, plus 1 more is 21. 2 times 10 is 20, plus 1 more is 21. We're just plugging 10 in place. Now xz, 7 times 10 would be 70, plus 11, which would give us 81. Now why did I write all three of these even though we already knew what yz was? Because if you add these two parts together, xy plus yz, you should get the whole thing. So part plus part equals whole. And even though we already knew what yz was, it doesn't hurt to rewrite it. It's okay if you write it in there. So those are the measures of our three, and they do add up to be the total 81. So we know that it's correct. Last one, number 7. Find the length of the unknown segments if s is between r and t. rs equals 4x. The measure, or rs is congruent to st, and the measure of rt is 24. Now, that's lots of stuff. So let's start one piece at a time. Find the length of the unknown segment if s is between r and t. and the measure of RS is 4x. Let's skip this statement for 1 second, but it's very, very important. You can't really skip it, but let's go ahead and do RT. RT, the measure of RT equals 24. So I'll put it down here since we've got plenty of room. Now, it says here, segment RS is congruent to segment ST. This is the most important statement here. Without this statement, you cannot finish this problem. Congruent, what does congruent mean? Congruent means the same measure. How do we show that in a picture? Well, if RS and ST are the same measure, we have to put a little hash mark or a double hash mark if you want on both to show that they're congruent. You have to have that in the diagram. You cannot finish this without it. Now that we have marked that, if these two are congruent, then what do we know ST has to be? Well, if RS is 4x, then ST also has to be 4x. So you just copy it over onto the congruent segment. And now you can finish the problem. So what I'd like you to do is go ahead and finish number 7, following the same steps we did in step 5 and step 6. Bring that to class tomorrow. What I would also like you to do is do problems 8 through 11, and bring those to class with you tomorrow. So you need to have this 5-minute check done. You need to have number 7 done. And in the end, you should have RS is equal to something, ST is equal to something, RT is equal to something, and you need to have your work here, okay? And then you also need to have 8 through 11 done. I'll check those when you come to class tomorrow. So remember, you can look up some of these ideas on the internet if you need any help, or you can help each other out too. That's fine with me. Just make sure you have them done when you come to class tomorrow.